We can oxidise both primary and secondary alcohols with common oxidising agents. In a primary alcohol, the hydroxyl group is bonded to a carbon that's bonded to two hydrogens. In a secondary alcohol, the hydroxyl group is bonded to a carbon that's only bonded to one hydrogen directly and two alkyl groups. Now this is important because it has an effect on the outcome of the reaction. If we gently heat a primary alcohol in the presence of an oxidizing agent, then our hydroxyl group becomes a carbonyl group at the end of the chain, which means that we have made an aldehyde, in this case ethanol. The O in brackets in this equation is simply a generic shorthand for oxidizing agent, and the oxidizing agent that I've chosen, in this case, is sodium dichromate, and we have our reaction under acidified conditions, hence the H+. Now we need to heat our reaction gently and distill off the product as it's formed, because otherwise our aldehyde would be further oxidized to form a carboxylic acid, and that's not what we're after. Note that during this reaction we are going to lose the hydrogen from the hydroxyl group, but we're also going to break the carbon-hydrogen bond. If our alcohol is being oxidized, then something must be reduced. This is a redox reaction, and the oxidizing agent is reduced. In this case, the chromium in the dichromate ion is reduced from an oxidation state of +6 to +3. And being a transition metal, we get this nice change in colour from red to green, which is really useful in telling us when the reaction is completed. Secondary alcohols are oxidized to form a ketone, and that is where the carbonyl group is in the middle of the chain. In this case, we have gone from propan-2-ol to propanone. We can use the same oxidizing agent, but our conditions have changed. Rather than distill off our product, we're going to heat under reflux for a period of time to ensure that the reaction goes to completion. Once again, because this is a redox reaction, we're going to get the change in oxidation state of chromium and a colour change from orange to green. Tertiary alcohols cannot be oxidized because the carbon that the hydroxyl group is bonded to is bonded to three alkyl groups. There's no carbon-hydrogen bond to break. So I can reflux this for as long as I like with whichever oxidizing agent I like, but nothing is going to happen. We are going to make precisely zilch. As always, you can find the notes for this on the Crunch Chemistry website. There's a link in the blurb below. And if this has been useful to you, then please like, subscribe and share. It makes a huge difference to a small channel like us. I look forward to seeing you next time.